Okay, so number 4 is, can you tell it's a parabola shape, right? And here's what happened. A ball was launched, so pretend you're throwing a baseball. Okay? That's the shape that it would follow. Okay? So you threw a baseball, and this is what happened. I want to know what's going on at these 3 points. Okay, so let's look at our variables. The x variable is the time, and the y variable is the height of the ball. So in our situation, we are throwing a baseball. What's going on at this y-intercept?
Because the height is 50 something.
Think about you throwing the baseball. What's happening with you in the baseball right now here?
You're on a hill. Wait, does that?
No, you're throwing the ball up, kind of.
But what's the situation here? So no numbers or anything. What's just going on?
Start from the height in the air.
The height. This is the height where I'm starting out. Does that make sense? Okay, so that y-intercept in this situation is telling me where am I when I'm starting. And you know that the y-intercept really is a coordinate 0, comma number, so the time is 0. Okay, so this is the vertex, and your vertex is it going to be something, comma something? In this case, it's like 3, comma 200. What does this tell me?
The time.
The time of what?
That it's going to be at that point.
The time it takes
To get there.
to get to, and what is special about that point? To get to the max.
Oh.
Remember, it's a special point, it's a max point. So the time it took to get there, comma, so in this case, the 200 would be what?
How high it is.
The max height of the ball. That's the highest the ball ever went. And it took, in this case, 3 seconds to get to the highest height. And this is an x-intercept, so in other words, an x-intercept would always look like that, a number, comma, 0. So think about you throwing a ball. What's happening to the ball right here?
It landed.
It hits the ground. It landed. It hits the ground. So what is this number? Let's say it's 7. 7 what? 7 seconds it took to hit the ground.
Where's the units of measure?
Okay? Does that make sense? The time it took to get there. Okay. This is how I would normally graph a parabola, right? And normally we say its domain is from negative infinity to infinity, right? This is what we normally say.
But since it hits the ground, it doesn't go on forever.
It doesn't go on forever. So the domain can't happen. The graph is restricted here and here. Why didn't I include this part of the graph? What's wrong with including that part of the graph?
It doesn't start in the negative?
What doesn't start in the negative?
The ball.
In the ground.
The ball would be moving back in time.
Back in time. Time? Can it be negative? That's not good. So that part of the graph doesn't exist because it would be like saying -1 second. The ball was here. That doesn't make sense.
Back to the future, when they only go to the future once, they should say blast from the
And why did I stop the graph and not continue it on this side?
Go on
That
forever.
one's going in the ground.
That one, now the ball is in the ground. The ball is in the ground there, so that's why I stopped the graph. Okay, let's look at number 3. So it told me that there was a frog sitting on top of a rock, and then it jumped into a pond, and it was with this equation. So we have a height in centimeters and a time in seconds. Okay, can you tell me 2 really quick things about that equation? What's something you know with the graph right now?
You can put 25 to the other side.
We can put the 25 where? On the y-intercept. That's a quick thing I know. And I also know something else quick. And here's your hint.
Going down.
It's a parabola heading down. So what do you think is going to be happening? The frog is going to be sitting on a rock right there. So this is the rock. It jumps up. The frog is going to, somewhere along the line, hit a highest point, and then it's going to
Fall. Jump.
splash.
Sorry.
It's into a pond. That's where it hits the water. How long does it take for the frog to reach its max height, and what is the frog's max height? So we want to know that point. And this is called the vertex, right? The highest point is going to be the vertex.
Do we have to do our equation too?
So we have to find a vertex using this equation. So what's the technique to get a vertex in this general form?
We can do the
Negative b over 2a,
or the other one.
comma, plug it in. The other one, you do not want to complete the square in this.
The numbers are.
The numbers are just not fun.
Okay,
Yeah.
that's what
Definitely. Are you trying the complete the square on that?
I think 75 squared.
Are you factoring out the 490? Okay. Can you go?
Big number.
Can you go 3 decimal places with this? Okay. So what are you putting here? Negative b. Negative 150 over 2 times negative 490. Can you give me 3 decimal places? It's a small number.
It's going to be a positive, that's all I know.
It is positive with negative negative. And it's time, so I hope it is positive.
Wait a minute. Why did I get 36,000?
Because you maybe forgot to put brackets. If you went this divided by this times this,
Oh, I put brackets.
you put brackets. Right when you type that in, can we all double check that we're typing that properly?
You
Properly?
need to put brackets around the 2 and the negative 490.
If you're doing this in your calculator, if you did that in your calculator, it will come out wrong. You would need
And it's
that.
36,750.
negative 150 divided by bracket
Negative 150, oh, sorry, negative 150.
divided by bracket
By bracket.
2 times negative 490. Bracket.
Okay, that point 153.
Everyone's good? What, 0.153? Okay. So our vertex is 0.153, comma. So I need to plug it in. So negative 490 times 0.153 squared plus 150 times 0.153. So I'm getting that. I'm putting that into my calculator.
You want two?
Just 2 is good on that one. Is it 36 point something?
Yeah.
48?
Yeah.
Okay, so that's the vertex. But what is what? How long does it take for that frog to reach its max height?
36.48 seconds. No.
This is the X and this is the Y, but we're not X and Y. What are our letters? Instead of X, we have a T, and instead of Y, we have an H. So when I say how long does it take, that is the 0.153 seconds. And what's the highest it goes? 36.48 centimeters.
Impressive, with less than a second to do that. I'm very talented.
Yes, it was really hard to make an equation that fits numbers. Okay, some of you are in applied, question mark, right, in second semester? Okay, so in applied, you have to do the same thing, but your calculator does it for you. So we'll check this out. You get this fancy calculator. Y equals negative 490x squared plus 150x plus 25. I'm going to graph it. I'm going to change my window to make sure that I think the x is not much. And the y has to go past 36, so I'm going to go to like 45. And is that a parabola?
Wow. That calculator's just smarter than me.
And now I'm going to go second calculate, and I'm going to find its maximum. And then it tells me, look, my mouse, here's my mouse, it says go left. Okay, I'm left of it, enter, go right of it, enter, get it. Here's my vertex, 0.153, comma 36.48. And it did it for me, right? Those are our numbers. I'm not going to make you do this in pre-calc, but when is the frog going to hit the water? Right over here. So I'm going to calculate the 0, and then I'm going to go, it's between here and here, and it took 0.425 or 426 seconds, and then the frog hit the water there.
So, are you expecting our calculators to do this?
No, 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 no.